Okay guys, so in this problem, hey guys, I'm trying to record a video, so if you could, thank you. Okay, should I start over? Okay, all right, in this problem, we start with a block of ice that has a mass of 348 grams and a starting temperature of negative 44.5 degrees Celsius. Okay, and then we also start with some amount of steam that has a mass of 95 grams and a starting temperature of 125.5 degrees Celsius. And what we want to know is if we mix the two of those in an insulated container, and then this one melted and this one condensed, by the time we're done, what would the temperature of that water be? That's what we're trying to find out. So to get there, we need a picture of what's going to happen in the energy. So here's a heating and cooling curve. This is the temperature in degrees Celsius, and this is the amount of energy that I've added. And so you can see that the ice is going to start here, and I'm going to add energy to get it to there, and add more energy to get it to there, and then finally add some amount of energy to get it to there. And the steam is going to start up here. It's going to lose energy to get it to there. It's going to lose energy to get it all the way to there. And then finally, it's going to lose some amount of energy to get it to there. And what we want to know is, what is that temperature? What's that temperature where the amount of energy that this one gained will be equal to the amount of energy that this one lost? So the way I decided to tackle this problem was to go ahead and calculate how much energy would it take to turn this ice into water at 0 degrees, and then how much energy would it take to turn this steam into liquid water, and then at 100 degrees. So here's how I did each of those calculations. The ice had two pieces. One, we had to increase its temperature from negative 44.5 up to 0 as ice. So that looks like this. It's the mass times the specific heat of ice times the change in temperature. So that tells us how much energy it takes to go from there to there. The next thing we want to calculate is how much energy to melt all of that ice. And so that's going to be this. This is the heat of fusion for ice. Basically how many joules of energy per gram. So I'll do all that calculation and add it up, and I'll get to some number. I get to 70,021. Nope, I get to this. 148,591 joules. All right. I put that much energy in to turn this into this. Okay, what about over here? How much energy do I have to put, or how much energy has to come out of the steam to get it from where it is down to being liquid water at 100 degrees Celsius? Okay, so first we've got to do the change in temperature. So that's going to be negative 25.5 degrees Celsius times 95.0 grams times the specific heat of steam Okay, and then we also need to do the energy, the heat of vaporization. So it's going to be negative 950. Okay, when I do all of that, I get negative 218,619 joules. Okay, so to get the ice from here to here, I have to put in this much energy. And to get the steam from here to here, I have to get out this much energy. Notice that they're not the same. So what that means is, in order to start from a even playing field, I need to take some of this extra energy and put it into that water at 0 degrees, so that I'm starting from like a even playing field. So the difference, the amount of energy I need to put into this water, so that the amount of energy that's gone into this will equal the amount of energy that's come out of that. I have to put in, if I subtract that one up here, 209, I get out something like 70,021. Okay, if I were to add this much energy to this, then I would have taken the same amount of energy out of that I put into this. So let's find out if I had 348 grams of water and I changed its temperature or I added 70,021 joules to it, what would the new temperature be? So grams times 4.18 joules per grams degrees Celsius times some kind of delta T equals 70,021. Okay, I do this and I solve for what this change in temperature would be, and I get that it must have been 48.1 degrees Celsius.
Can I have Vanessa's number?
Vanessa? I don't think she's here. Vanessa? No. Sorry.
Okay, thank you.
Okay. All right. So what this is saying is, if you started with ice at negative 44.5 degrees and you heated it all the way until it was water at 48.1 degrees, you would have added the same amount of energy to this as you took out of the steam that started at 125 and came to 0, or came to 100. The final step, now we need to add these two things together and figure out what would the final temperature be. So, this is the problem we've done several times now. And the idea is that the energy on this side is going to equal the energy that came out on the other side. So 348 grams times 4.18 joules per grams degrees Celsius times whatever this final temperature is going to be. I'm just going to call it X. So that final X minus 48.1 is going to be equal to the amount of energy that would have to come out of this water in order to reach an equilibrium temperature. So this is 95. And this is going to be this. And now we can solve for X. One little trick is that's the same on both sides. So we get something like 348x minus 348 times 48.1 negative 95x plus 9500 And then we solve for x, and you get x equals 59.23 degrees Celsius. In terms of significant digits, I think, okay, that one we just had 3, so report it like that is the best. Anthony, did you see that? That was for you. It's okay, there'll be a video. Yeah, that's good.